Okay, college algebra 4.6. This is going to be the first video. And this section, this is the last section of the chapter where we're going to pull all the logarithmic things together that you've learned and do story problems. One of the nice things about these story problems is they will give you the formula, and sometimes most of the time that's the hardest thing about setting these problems up, is coming up with the formula, but they're already doing that. So, first section is called population growth, and they give you a formula, and I'm just going to write it down on here so that we have it. The population given a certain amount of time equals P with a sub-zero, or an O, not a zero, O. That's the initial population, to the E, to the K, T, and K has to be bigger than 0, because what would happen if K was 0? 0 times whatever time would be, this would turn into a 0. Anything to the 0 power is a 1, and then it would be this initial population times 1, which would give you the initial population. So even if you said in 400 years, what's the population going to be? It's going to be the original 1, because everything cancels. So it has to be greater than 0. It's the exponential growth rate is what K is. Okay, so T is time, original population. You know what E is. K is the exponential growth rate. Okay, so let's look at example 1, talking about China. 2005, the population of China was 1.306 billion, and the exponential growth rate was 0.6% per year. Find the exponential growth function. So what they want us to do is find the equation for this particular problem. This is the general form of the equation that works for every single population growth. We're talking about China. So we're going to take this equation and set it up for China and have a general equation for China that we can put however much time we want in here, and it will give me what the population will be that many years from 2005. Okay, so if it was 20, if T was 20, then it would be, what will the population be in 2015? Okay, so it has to do with 2005. All right, so estimate the population in 2008, and after how long will the population be double what it was in 2005? So we have 3 parts to this. So the first thing we're going to do is find the exponential growth function, find the equation, and it will always have the P of T, so that won't change, and the P of 0 will be what is the initial population. So what is the population in 2005? So the population in 2005 is 1.306. E, and would they say the exponential growth rate was 0.6%. So we have to change that to a decimal. 0.006. So 0.006 T. So there is my A. I just set up an equation. So now I can put any number in here for T, and it will spit me out the population. Alright, so in B, that's what they want to know. What will the population be in 2008? So what will the population be in 2008? Well, we started with 2005, so in 2008 it'll be 3 years, right? So in 3 years, whoops, so this multiplied together gives me 0.018, so I have 1.306 to the 0.018 power. Whoops, forgot the E. So E to the 0.018 power times 1.306 gives me a population of 1.33 billion. So I started with 1.306 billion in 2005, and in 2008 it jumped to 1.33. If I wanted to know what the population would be in 2030, I would put a 25 here for this number and this number, because 2030 is 25 years past 2005, and that's what our initial time was. All right, so let's see what C says. After how long will the population be double what it is in 2005? Now this is called doubling time. So what we're doing is we're looking for a different formula here called the doubling time formula, and the doubling time formula means that we are looking for, the book uses a capital letter T for a doubling time instead of T for how many years after the initial. Okay, so this means in what will the population be, when will the population be double? What will P of T be? So we're looking at what will the population, how long will it take for the population to double? Well, what is it now? 1.306. So 2 times 1.306 would be double the population, and that equals 2.612 billion. So I am looking at what my T will be when my P of T is 2.612. So let's put 2.612, which is going to be basically this number here that we are usually finding, and this time we're given that, equals and we're looking for the T, right? So this is what we don't know. When we did this one up here, all these up here, it was easy. We had numbers for everything over here, and we found the population in 3 years after 2005. Well, now we're given the population, the double, and now we're looking for T, which is in an exponent position, which means logarithms. Let's get all this out of the way here so we can make this work. All right. So since we're dealing with logarithms, and since we have a natural logarithm, or we have an e here, we're going to do natural logarithms. So we're going to do what math we can. Okay, so we're going to divide. Before we deal with logarithms, we'll just do what we can here. And this is going to be 2. Okay, nothing really weird there. Now, remember what I said, when we have logarithms and we want to figure this, or when we have it in exponential form and we want to figure logarithms, we take the logarithm of both sides. Okay, and from your handy dandy deal, you know that when you have an ln of e, this goes away and it equals that. So what we're going to have then is ln of 2, nothing happened to that. This goes away, so that equals 1, or I guess it doesn't even equal 1, but well, it does, because this then goes to the front, and then this here, ln of e is 1, so 1 times this is this. Okay? So again, the ln of e equals 1 is the property on the top of page 381. They give it to you. So whenever you have an ln of e, which is nice to have, like we had here, it's actually equal to 1. Okay? So, and again, remember your exponents go in front. So ln of e is 1. 1 times this is this. Alright, so that's what we have here. Alright, so what do we do with that? Well, we divide both sides by 0.006. That all cancels. And then we find out t is a number similar to 116. So the Chinese population will double 200 or 116 years after 2005. So it will double in what, 2121, something like that. Okay, so we don't have to worry about the population doubling for a little while anyway. Okay, so you see what I did there? When your exponents have a variable, you have to use logarithms to solve it. When your variables are not in exponents, you don't have to use logarithms to solve it. Okay, so let's get rid of all of this. And the second part, bottom of page 411, is when interest is compounded continuously. Okay, that means that every second of every day your interest is being compounded instead of every 3 months or every 6 months. It's like every second of every day. So we have a different formula. Looks very similar to the one we did on population growth. Okay? The only difference is, well, the formula is the same. The only difference is what K stands for. K was the exponential growth rate in population, but in interest, it's the interest rate that is being compounded continuously. All right, so when we look at example 2, it says, suppose that $2,000 is invested at an interest rate of K, compounded continuously, and grows to $2,983 in 5 years. So what is the interest rate? Well, let's go ahead and write down what we've got. We know that in 5 years, we have $2,983.65, right? Okay. So we know that this number here is $2,983.65. That's how much we're making given a certain amount of time. We know that we started with 2,000. We know we're looking for K. And again, we know our time is 5 years. Okay, so this is in 5 years. They gave it to us in the problem. It grows to that in 5 years. So we're saying, all right, in 5 years, this is how much money I have. This is how much I started with. This is how long it's in there. How much is my interest rate, K? And again, see, the K is in the exponent position. So we're going to take logarithm eventually. But let's get rid of the 2,000. So that goes away. So now we're going to take the ln here and the ln of here. And again, what happens when we have that ln of e? Good things happen. It goes away and we just have 5k. So let's get rid of all of this. Oh, I can't get rid of all of this. And that equals 5k. Okay, so now I have ln of this equals 5k. So I don't have a calculator with me, but take this, divide it out, take the ln, so you're going to have ln of whatever that divided out to be, which I don't know, equals 5k, divide by 5, divide by 5, that cancels, and your k then will be a number similar to 0.08, or 8% interest. So that was the first part that we're looking for, was A. So I'm going to shut this off, and we'll continue on with this example 2, and we'll do B, C, and D on the next video.